Hi, my name is Dr. Tishan, and in this video I'd like to go over the methods of solving a quadratic equation versus solving a quadratic inequality. Let's start with solving a quadratic equation. The quadratic function used in these is factorables. So we're just going to factor the left-hand side of the equation. We're going to factor the left-hand side. Okay, so just remember when we're factoring, we want to x times x is x squared. We want to take a look at these numbers here, and we want to figure out which two numbers give us a product of negative 15 and a sum of positive 2. So as you go through and work it out, positive 5 times negative 3 will achieve that for us. We have x squared plus 5x minus 3x gives us 2x, and then 5 times negative 3 is a negative 15. So we want to solve this quadratic equation. Quadratic equations can have up to 2 real solutions, okay? So up to 2 real solutions. This one is going to have 2 real solutions. To solve the quadratic equation, we're going to take each of the factors that we've generated, and we're going to set each of the factors equal to 0 and solve for x. So we set each of the factors, x minus 3 equals 0, x plus 5 equals 0. X plus 5 equals 0, subtract 5 from both sides, so x is in negative 5. Here's one of our answers. And then x minus 3 equals 0, add 3 to both sides, so x equals a positive 3. So the solutions to this quadratic equation, we have x is negative 5, x is positive 3, and you could just go ahead and substitute those back in to check. So remember, the quadratic equation has up to 2 real solutions. So we'll let this one stay here. Now let's look at the method of solving a quadratic inequality next. Solving a quadratic inequality, the method is a little bit different than solving a quadratic equation. We don't want to use this process. A little bit different. We do start the same way. We want to factor. Okay, just make sure all terms on the left and a 0 on the right. And then again, it's factorable. This is the exact same quadratic function as over here. So we can see that the factors are just going to be x plus 5 again, and x minus 3. So we want to start by factoring. All right. So next, now we do not use the process of drawing the tree and setting each factor greater than 0. Don't do that with a quadratic inequality. With a quadratic inequality, we are going to solve this on a number line. So we want to just draw a number line, spans from negative infinity to infinity. Okay, it's just infinitely long. It just keeps going off to infinity, negative infinity. And then what we want to do is we want to actually take the zeros of the quadratic function. We want to take the zeros, and we want to plot those on our number line. We've already solved for the zeros over here, so we can see the zeros are negative 5. Okay, so the zeros would be negative 5 and positive 3. All right, so negative 5 and positive 3 for the zeros. So then what we want to do is we're just going to pick a number in each of our intervals we generated, and we're going to test a number in each interval. All right, pick any number in the interval. We're going to pick a number in the interval negative infinity to negative 5. Pick a number and see if it works and makes a true statement for our quadratic inequality. We'll pick a number between negative 5 and 3, and we'll pick a number from 3 to infinity. And we just want to see which of the intervals would contain our solutions. If our test number works in the quadratic equation, if it generates a true statement, then the interval would be representative of our solution. And if it doesn't work, then it generates a false statement. It wouldn't work. So let's start right here. Let's test a number between negative infinity and negative 5. So let's say negative 6. Okay. So we test negative 6, just plug it in, doing some mental math here. Plug in negative 6. Negative 6 plus 5, that's going to be a negative 1. And negative 6 minus 3 is a negative 9. Negative 1 times negative 9 is positive 9. Positive 9 is bigger than 0. This generates a true statement. So our solutions, negative infinity to negative 5, will be one of our intervals containing the solutions for this quadratic. Now, between negative 5 and positive 3, let's pick a number to test in this interval. Now, 0 is in there. I always like to choose 0 if it's in the interval. It makes the mental math a little bit easier. So you take 0 and plug it in, gives us 5 times negative 3, which is negative 15. And negative 15 is not greater than 0. This generates a false statement. So we have a false statement in here. And then one more interval to test. Let's pick a number to test between 3 and infinity. So we need any number between 3 and infinity. Maybe x is 4. 4 is between 3 and infinity. 4 plus 5 is 9. 4 minus 3 is 1. 9 times 1 is 9. 9 is greater than 0. This is true. So we have our true, so our intervals that work would be negative infinity to negative 5, and then 3 to infinity. So now you just need to check the endpoints. Check negative 5 for this interval here. Well, we are not including 0. We're not including 0. So we want all the numbers from negative infinity to negative 5, but when we get to negative 5, we do not want to include negative 5. So just shade our number line so we can see where the solution is. But don't include negative 5. It's not inclusive in our quadratic inequality. And then 3, again, it's not inclusive, so we don't want to include the 3. And then you can shade your number line, and this is where you would have your solution, okay? So to write our solution properly, we would generate negative infinity, okay? Put a parenthesis around that to negative 5, all right, parenthesis. We do not want to include, and then or, the symbol for or, because we have the two different intervals to represent, and we have 3 to infinity. Right, so this is how we would generate our answer. And this is our solution to this quadratic inequality. I would like to make a note on this. I would like to note that an incorrect method, okay, so let me just please note this incorrect method okay, and the incorrect method that I've seen sometimes happen in the thought process of some of my students, the incorrect method is when you take the process to solve a quadratic equation and use it to solve a quadratic inequality. To solve a quadratic inequality, we want to factor the left-hand side, all terms to the left, and factor 0 on the right, okay? And then once we're done factoring, you have to plot the zeros on a number line, test the intervals, and that's the correct method. The incorrect method is to, if you went ahead and used this process, if you took the x plus 5, some students do this, set that greater than 0, and then the x minus 3 factor, set that greater than 0, this would be incorrect. All right, we're not going to take each of the factors and set them greater than 0 as we do with an equation. If we did that, subtract 5 from both sides, we're saying x is greater than negative 5. X is greater than negative 5 for a solution. We can clearly see that x is not greater than negative 5. X greater than negative 5 generated false solutions here, so this is incorrect. You want to be sure when you're solving a quadratic inequality, you want to be sure that you're not using the quadratic equation process to solve the inequality. So if you're solving a quadratic equation, we factor, then we set each factor equal to 0, and we get up to 2 real solutions, maybe 1, maybe none. When you're solving a quadratic inequality, we factor first, but then we draw a number line, zeros on the number line, test each of the intervals. You will have infinitely many solutions, you will have intervals of solutions, and you need to test the interval to see where the solutions lie. So, and please note, this is an incorrect method of solving. You don't want to use the method over here when you're solving inequality. So if it's a quadratic equation, here's your process. Quadratic inequality, it works that way. Well, that's it for this video. Thank you for watching, and see you in the next one.